Welcome to this video on practicing writing hypothesis statements. Let's begin. After watching this video, you should be able to write hypothesis statements for each of the 5 types of hypothesis testing mentioned in this video. Let's review the steps on deciding what type of hypothesis test you are being given. One question we always need to ask ourselves is, how many samples do we have? We could have 1 sample or 2 samples. If we have 1 sample, then we have to ask ourselves, what data type are we being given? Our choices are either categorical, which is also known as qualitative data, meaning labels, or we might be given quantitative data, which is counts and measures. If we are given categorical data, then our population parameter is the population proportion, P. If we're working with quantitative data, then the population parameter is going to be the population mean, mu. But what if we have 2 samples? First, we have to ask ourselves, again, what data type are we being given? Categorical data or quantitative data? If we have categorical data, then our population parameters, notice there are 2 now because we have 2 samples, are the population proportions P1 and P2. If we have quantitative data, meaning counts or measures, we have to ask ourselves another question. The question we have to ask now is, do we have dependent or independent samples? If we have dependent samples, then our population parameter is going to be the mean difference, known as mu sub d. And if I have independent samples, then the population parameters are mu1 and mu2. So I can summarize this whole entire graphic by simply asking 3 questions anytime I go to do a hypothesis test. I need to ask myself, how many samples do I have? What data type is provided? And then if my answer is that 2 samples and a quantitative data type is provided, then I have to ask myself this 3rd question, which is, are the means independent or dependent? But notice it doesn't matter what order I ask myself the first 2 questions. In other words, I can first determine the data type and then the number of samples, or I can determine the number of samples first and then the data type. However, I need the answer to number 1 and number 2 before I can answer number 3. Let's review the hypothesis statements associated with each of the 5 types of hypothesis tests. If we have 1 proportion, what is our null hypothesis? Pause this video, jot down your answer or have it in your head, and then unpause that to see if you're correct as we go through this table. So the null hypothesis for a 1 proportion hypothesis test is P is equal to some value, which will be provided in the problem. What about if you have 2 proportions? What's the null hypothesis then? Well, it would be either P1 is equal to P2 or P1 minus P2 equals 0. Those are algebraically equivalent statements. What if you have 1 mean? Well, then we have mu is equal to some value, which again will be provided to you in the problem statement. But what if we have 2 means independent samples? Well, then our null hypothesis is either that mu1 is equal to mu2, or equivalently, we could say that mu1 minus mu2 is equal to 0. Last but not least, what if we have 2 means with dependent samples? Then our null hypothesis is that mu sub d, the mean difference between the 2 samples, is 0. So now we are going to work through 5 different examples, 1 of each type, and we are going to practice answering these 3 questions so that we can write our null and alternative hypothesis statements. So let's get started. Example 1, hospital vaccinations. 2 hospitals want to compare the effectiveness of their flu vaccination awareness campaigns. Hospital A randomly surveys 150 patients and finds that 90 of those patients were vaccinated. Hospital B randomly surveys 200 patients and finds that 100 of the patients were vaccinated. You want to test if the proportion of vaccinated patients in Hospital A is significantly larger than that of Hospital B. Write the null and alternative hypothesis statements for this scenario. So remember our 3 questions. How many samples do we have? And what data type is provided? So let's just start with the first 2, because again, we may or may not have to answer the 3rd question depending on the answer to the first 2. So how many samples? That's pretty straightforward, right? We have 2 hospitals, so we have 2 sample summaries. Okay, so we have 2 samples, and what type of data is provided? Again, I encourage you pause this video as we go along so you can answer on your own before I give you an answer, because the whole point is not me talking to you, it's you honing this skill. So Qualitative or categorical data, how did I know that? Is it because I'm psychic? Is it because I wrote this problem myself? Nope. It's because there's some keywords here, right? One keyword is the word proportion, right? And then what are we talking about? Are people vaccinated? Well, what's the answer to the question, are you vaccinated? It's yes or no, right? That's a label, right? And also 90 out of 150 is not a proportion, right? That's a part of a whole. Also, right, 100 out of 200, also a proportion, also part of a whole. Okay, so I want to ask you, do we even need to answer this third question? We have two samples, but do we have quantitative data? No, so we don't have to bother with this third question for this particular problem. So here are our 5 hypothesis statements. Again, pause this video, figure out which of these 5 is appropriate in this question. If you said 2 proportions, then you are correct, and there we go, we have our null hypothesis for this question. So the null hypothesis, you can either write it as P1 equals P2, or you can rearrange it algebraically to say P1 minus P2 is equal to 0. But first of all, what is P1 and P2, right? Obviously, they're proportions, right? But we have to assign 1 to one of our populations, and we have to assign the number 2 to another population. So just to be simple and straightforward and not get too confused, let's call hospital A our population 1, or P1, right? And hospital B will be population 2. So P2 will be associated with hospital B. So that's really important when we get to defining our alternative hypothesis, right? So where is the key phrase in this question that is going to tell us how to construct our alternative hypothesis? Well, it's right here. It says you want to know if the proportion of vaccinated patients in hospital A is larger than hospital B. In other words, we think that P1 might be bigger than P2, or again, if you subtract P2 from both sides, just use some algebra there, then we have P1 minus P2 is greater than 0. So that is our alternative hypothesis for this example. All right, let's do another example. A company claims that at least 90% of its customers are satisfied with their service. A consumer rights organization believes this claim may be exaggerated and decides to test it. Write the null and alternative hypothesis statements for this scenario. So we have our 3 questions. How many samples? What data type is provided, right? And we'll skip number 3 for right now. So how many samples do we have? Well, we just have 1, don't we? Oh, okay. Well, what data type do we have? Well, we have qualitative or categorical. How do I know that? Well, there's a few things. One is I'm giving a percent. I'm given a percent here, right? So that's a huge clue that I have qualitative data. But maybe it's not. Maybe I'm not sure, right? So what is this problem really talking about? It's asking me about customer satisfaction, right? If you send out a survey to your customers and say, are you satisfied, right? They're probably going to say, hopefully, yes or no, right? So that is a label, right? How you would respond to, are you satisfied? That is going to be qualitative data. It's not going to be quantitative data. Okay, so do we even need to answer number 3 in this particular instance? We do not. We don't need that one. Okay, so here are our 5 types of hypothesis tests and the null hypotheses associated with each one. So which one do we need? We have one proportion, p is equal to some value. Okay, so the value in this case is 90%. Again, that is the null hypothesis. We're going to assume that unless we gather sufficient evidence to debunk this claim, that we're going to assume that this is true. Okay, but what about our alternative hypothesis? Well, it says that they think that this is too high of a number. It's exaggerated, right? In other words, they think that probably fewer than or less than 90% of the customers are satisfied. Because making 90% of any group of people happy, that's pretty crazy, right? That's pretty hard to do. Politicians never manage it, right? They're lucky if they can get 50%. All right, so now on to example 3, a new teaching method. So in this example, we have a school that wants to know if a new teaching method improves student performance. They randomly assign students to one of 2 groups. One group of students is taught using the traditional method, while the other group of students is taught using the new method. Use the data set provided to determine if there's a statistically significant improvement in the mean exam scores in the treatment group. And again, I'm not trying to give you the data set. I didn't make up a data set. Just using this, right, what we want to do is answer those 3 questions. which is how many samples are we talking about and what data type is provided, and if needed, we'll answer question 3. So how many samples? Well, we're talking about 2 groups, aren't we? So we're going to have information, we're going to have data on both groups. Okay, then what kind of data are we talking about? Well, you have to probably read the question carefully. You might have to read it a few times, but it asks you if there is an improvement in the mean exam scores. So an exam score is either a point or percent, so that's a count or a measure, right? And also the word mean kind of suggests that it's probably quantitative data. So in conclusion, we have 2 samples and quantitative data. So guess what? We do have to answer this third question. And this is probably the hardest part of deciding what kind of hypothesis test you're doing. So I want to encourage you to pause this video and see if you can answer, are these independent or dependent? So the answer is that they're independent, and I'm going to tell you why, right? Because that's the more important thing. Right, we have 2 completely different groups of students, and there's nothing in here to suggest a way of pairing or matching student A in group A to student B in group B, right? Again, the example that I gave when I talked about and introduced the idea of dependent means is that we usually have a single test subject, whether it's a person or a thing, and we have a before and after. So it's true that we are applying a treatment here, but again, there isn't any way to suggest or anything in here that suggests pairing one student with another student. And again, you can see that there are 2 completely different groups of students. It's not the same group of students before and after the treatment of the new teaching method. So that's why we are saying that there are independent means. So take a minute to decide which of these 5 hypothesis tests do we have, which of these null hypothesis statements is appropriate. So if you said 2 means with independent samples, that is correct. So either mu1 equals mu2 or mu1 minus mu2 is equal to 0 is going to be our null hypothesis. So we know our null hypothesis, so now we have to do our alternative hypothesis, but remember we can't really do that until we define our populations, right? Mu1 is the average of which population? Mu2 is the average of which population? So let's just say that population 1 is the students with the traditional method and population 2 is the new method, okay? So if we define it that way, again, we have our null hypothesis. So what are we looking for? An improvement, meaning an increase, we would assume, in exam scores, right? The higher your exam score is, the better you did. That's usually how exams work, right? So in other words, the mu2, the treatment group, the group getting the new teaching method, we would want their exam scores to be larger or higher than the group with the traditional method. So in other words, the traditional method group, right, mu1, we expect their exam scores to be less than mu2, because if I say that mu2 is greater than mu1, that means that mu1 is less than mu2. Or you could say mu1 minus mu2 is less than 0. All right, let's do another example. In this example, a food manufacturer claims that the sugar content in one serving of its cereal is less than 10 grams per serving. You collect a sample of 30 servings and find an average sugar content of 9.5 grams with a standard deviation of 1.2 grams. Is there sufficient evidence to support the claim at the 5% significance level? So the claim is that it's less than 10 grams per serving. So again, we have our 3 questions. Well, maybe 3, at least 2, right? How many samples? Just 1. You just collected a sample of 30 servings of cereal, right? So we have 1 sample. What data type? Well, we have grams. Is that a count, a label, or a measure? It's a measure, right? We are measuring the weight of sugar. Okay, so we have 1 sample and quantitative data, so we don't have to worry about answering number 3. So if we have 1 mean, then that means we're going to look at this null hypothesis. Okay, so the null hypothesis is that the average sugar content is exactly 10 grams per serving, right? Alternatively, it's that the mean sugar per serving is less than 10 grams. All right, last example, fuel efficiency. An automobile repair shop claims that it can increase fuel efficiency by giving your automobile a tune-up. The highway miles per gallon fuel usage on 30 randomly selected vehicles was measured before and after the tune-up. Is there sufficient evidence at the 5% significance level to suggest that the tune-up is effective at increasing fuel efficiency? Use the data set provided. Again, didn't actually make a data set here, just made up this problem. So we have to answer our 3 questions. How many samples would we have if we had a data set? What kind of data is provided? And maybe we have to answer number 3. So we have the before and after, right? Doesn't make any sense if I don't have both pieces of data. I can't answer this question, okay? So we have 2 samples, the before tune-up and after tune-up, okay? What kind of data is provided? Well, we're talking about highway miles per gallon fuel usage. So we measure miles, we measure gallons, right? So this is definitely a measure. So we're working with quantitative data, okay? So we do have 2 samples. We do have quantitative data. So we do have to answer the 3rd question. Again, pause this video, think about it, process it, and then unpause it. So the answer, if you haven't already figured out, is dependent samples. By process of elimination, it kind of had to be, right? Because that was the only example we hadn't done yet. So to determine the efficacy of the treatment, we would need to compare the usage of the same vehicle before and after the treatment. In other words, right, if you have this huge SUV and you compare that before data to the efficiency of a smart car after the tune-up, that makes no sense, right? You have to take the SUV's before data and compare it to its data after. You have to take the smart car's fuel efficiency before the tune-up and compare it to its own fuel efficiency after the tune-up. So we definitely have a matched pairs situation. So which of these scenarios is the appropriate one? Well, it's 2 means-dependent samples, which means that our null hypothesis is this guy right here. Okay. So before we get into writing our hypothesis statements, we have to define the difference. Remember, we have to subtract our data points before we average them out. So we either have x1 minus x2 or x2 minus x1. Again, the choice is ours. It's arbitrary as long as we are consistent throughout the problem. If you try to switch x1 and x2 halfway through, you're going to have serious problems. So don't do that. Okay, so x1 I'm calling the fuel consumption before the tune-up. Okay, I'm going to call x2 the fuel consumption after the tune-up. So let's just do x1 minus x2. Again, completely arbitrary and random. I could have just as easily done it the other way around. I just picked one. Okay, so let's think about this. If the tune-up is effective, we would expect each automobile to consume less fuel per gallon, right? Meaning that the miles per gallon would be higher because it can drive more miles on the same amount of gas. It can go further on a gallon of gas. So we would expect the miles per gallon after the tune-up to be larger than before the tune-up. In other words, we would expect x2 to be greater than x1, again, if this is effective, if the claim is true. Okay, so if x2 is greater than x1, then see if you can use that information to write your alternative hypothesis. So we already know that our null hypothesis is mu sub d is equal to 0, meaning there wasn't any difference. The tune-up didn't do anything. Okay, but if x2 is greater than x1, in other words, I can go more miles on the same fuel after my tune-up than I could before, right? Then basically what I'm doing is I'm taking a smaller number and I'm subtracting off a larger number. So if I have a smaller number minus a larger number, that's going to give me a negative value. Okay, so that means my alternative hypothesis would be that my average difference is less than 0. And again, if I had changed this orientation, if I had made d equal to x2 minus x1, then my alternative hypothesis would have been mu d greater than 0. So the alternative hypothesis, it all depends on how you define this difference. So having watched this video, you should be able to write hypothesis statements for each of the 5 types of hypothesis testing mentioned in this video. And again, just as a disclaimer, I have exposed you to this information. It's not expected that you would be proficient at it. You're going to need lots and lots and lots of practice to strengthen this skill.